So application of Lami's theorem. So what we have got here is there is a ceiling and then the side wall. A mass m is suspended by means of a rope with a knot here. So because there is a knot over here, and you see, because the rope is actually supporting the mass. So what is the meaning of that? Mass is m, the downward gravitational force is mg. So the downward gravitational force is mg. In order to support this force, there has to be forces on these two strings. Because there is a knot, force on this string is different from force on this string. So the force on this string we call tension. Tension is a force that exists in a string. So we are going to call the force on this string is as T1, force on this string as T2. And one of the important property of the tension, as you are holding the rope also, you know that when you are holding a rope, the rope seems to be pulling you onto the opposite side. So if there is a point of contact, the force or the tension in the point of contact will be opposite to the point of contact. So, and this is a point of contact, T2 will be opposite. And T1 is acting this way, T2 is acting this way, and mg is acting downwards. This angle is 60 degree, and if you draw a vertical line over here, if this is 60 degree, this angle is going to be 30 degree. So this is 30 degree. So you know, like, what is Lami's theorem? So when three forces act at a point and the point is in equilibrium, equilibrium means it is at rest or moving with constant velocity. Let's say this is the point. This point is not moving to the right or left or upwards or downwards. So this is at rest under the action of the tension T1, tension T2, and the downward force mg. So now all three are acting at that point, let us say O, keeping the point at rest. If under the action of three forces, if the point is at rest, according to Lami's theorem, force 1 by opposite angle equal to force 2 by opposite angle equal to force 3 by opposite angle. Then if the question is to find out tension 1 and tension 2, which are unknowns, because m is the mass which is known, hence gravitational force is known. So T1 by opposite angles, since these two are right angle to each other, so this is 90 degree. So T1 by sine 90, that is equal to T2 in the opposite angle. If this is 30, the remaining angle between the other two forces is 180 minus 30. 180 minus 30. So we call this T2 by sine of 180 minus 30, which will be equal to force 3 by opposite angle. So this is 30, this is 90. So this opposite angle is sine of 90 plus 30. So mg by sine of 90 plus 30. Now T1 by sine 90 is 1. T2 by sine of 180 minus theta is sine theta. So this could be written as sine 30 degree. Sine 30 degree is 1 by 2, and that will be equal to mg by sine of 90 plus theta is sine of 90 plus theta is cos theta, which is cos 30 degree. So cos 30 degree is root 3 by 2. Root 3 by 2. So equating these two, we will get T2. So this is T2 by 1 by 2 is 2T2 equal to 2 mg by root 3. You will be getting T2 as mg by root 3. And then equating these two, you will be getting this one. So T1 equal to mg by root 3 by 2 can be written as 2 mg by root 3. So these are two single steps. We'll be finding the tension T2 as mg by root 3 and T1 as 2 mg by root 3. The problem isn't over yet, so I'm trying to explain like how this works and how it is balancing. So let us go for one more step, how this really works. See, this is the tension T2 and this is the tension T1 and this is the force mg. Now these are three forces, so mg and T2 and T1. So T1 is greater, Now what is T1 minus T2? So T1 is greater than T2 anyway. So in order to do that, what you are supposed to do is you have to, whenever you have to subtract one vector from the other, and what you are supposed to do is you are supposed to just change the direction, give a 180-degree rotation to that vector. So this vector, let's say T2, then let's give 180-degree rotation. Now this is actually minus T2. So this is minus T2 because T2 is in this direction. This is opposite to that. So it is minus T2. So we'll be writing it as minus T2. So the difference. So what you are supposed to do? What is T1 minus T2 is this. So this is the difference from T2 to here. So this is actually what the difference. So actually this length has to be like exactly equal so that it will cancel out. So I just drew this length a little bit longer, that's it. So T1 minus T2. So this is T1 minus T2. What we have found out here is mg by root 3 as T2. This is mg by root 3. And this is hypotenuse side is 2mg by root 3. This side is T1 minus T2. The magnitude of T1 minus T2 is the hypotenuse side is 2mg by root 3. This is mg by root 3. So T1 minus T2 is actually root over this T1 square minus T2 square. And T1 minus T2's magnitude is equal to root over 2mg by root 3 whole square minus mg by root 3 whole square. So because how this balances mg, that's what we are finding. So root over, so this is mg square and mg square, we can take mg square out. So mg square out. So this is 4 by 3 minus 1 by 3. This is what it is. So now root over mg square into 4 minus 1, which is 3, root over mg square is mg. So know that the resultant of T1 and T2 is exactly equal to mg and opposite to mg, so that it is balancing each other. And that's how we derived the Lami's theorem. I hope you have watched the Lami's theorem example, the derivation which I have done. So if not, please watch that.